Okay. Some of the problems on the test will say, okay, given that the sine of x is equal to, let's do an easy one first. The sine of x is equal to 4/5 and 90 is less than or equal to x is less than or equal to 180. Find the tangent of x. Now before we start these problems, I should have done this already, but before we start this problem, remember this, that the cosecant of x is the reciprocal of sine. And sine is actually, if for some reason you had cosecant, sine is the reciprocal of cosecant. So if you don't have these written down, write this down. Cosecant and sine are reciprocals. Secant of x is equal to 1 over cosine. And cosine is 1 over secant. Cosine and secant are reciprocals. And you might be saying, I thought you just flipped them. That's what this 1 over does. Think about if cosine was 4/5. 1 divided by 4/5. How do you divide by fractions? Don't you flip and multiply? So 1 divided by 4/5 would be 1 times 5/4. What's that going to do? It's going to flip it. So anytime you need to flip a fraction, you can write it as 1 over that fraction. And the last one, the cotangent of x is equal to 1 over tan. Or tangent and cotangent are reciprocals. So tangent of x would be the flip of cotangent of x. These are called your reciprocal identities. We'll talk more about those later. Reciprocal identities. Okay, so now back to this problem up here. Because on some of them they're going to ask you for secant, cosecant, cotangent, all those. That's the reason I went ahead and gave you those. So given one, find the others. If you're given that the sine of x is 4/5 and this is what we need to interpret for you. This is what might not make sense. 90 degrees is less than or equal to x is less than or equal to 180. When you saw that the last time you took your ACT, that didn't make much sense. Hopefully it does now. X is between. X is bigger than 90, x is smaller than 180. You know what all this tells you? You know what it is? You're in quadrant 2. That's all that means. From what we graphed a while ago, here's 90 degrees and here's 180 degrees. If x is an angle somewhere between 90 and 180, that simply means that x is somewhere in that second quadrant. That's all. Okay? So why is that important? There's only one reason that that's important. Does everybody understand that sine is positive in that second quadrant? What are you finding though? Tan. What's tangent going to be in that second quadrant? All students take calculus. Tangent is negative. Because cosine is negative, sine is positive, sine over cosine would be negative. That's the reason tangent is negative. Or look, I told you tangent is slope. If I were to draw any angle here, doesn't that line have a negative slope? Isn't it slanting down? You see that? Any tangent here would be positive. Any tangent here is positive. It's uphill. Any tangent here or here would be negative because both of them are downhill. Okay? So therefore, that's all you need this information for. This information tells you whether your answer is positive or whether it's negative. So now let's actually work it out. Here's all you have to do. This is the easy way. Draw yourself a little right triangle. Here's my x. Sine is 4/5. And a reminder that sine is opposite over hypotenuse. So that is 4 and that is 5. Again, this is the easy way of doing this. I'll show you the more difficult way in just a second. Always know those two triples that I gave you a while ago because they have to. They have to use those to save time. 4, 5, that would be a 3, 4, 5 right triangle. If you don't know that, Pythagorean theorem tells you the missing side. So the tangent. Now that you have labeled with the sine the opposite and hypotenuse, and we found the adjacent, I can now find tangent. Tangent is opposite over adjacent. So if the sine is 4/5, the tangent is 4/3. There's a problem with that though, and it all revolves around this. Since you're in the second quadrant, if you put 4/3, and will 4/3 be an answer choice? Yes. If you put 4/3, it's wrong. Since you're in the second quadrant where tangent is negative, make sure you put a negative on that 4/3. Okay, that's a simple one. But what I'm about to do is I'm going to show you, okay, given sine, we can actually find all the other 5. Because we could find cosine by doing adjacent over hypotenuse. Cosine would be 3/5. Since it's in the second quadrant, it would be negative. So negative 3/5 would be cosine. And we can use all these reciprocal identities, now that we have sine, cosine, and tangent, to find cosecant, secant, and cotangent. So I'm going to work one more of these. Given that, I'm going to work one more the easy way. Let's do a tangent one. Given that the tangent of x is equal to 5/12. Those are some numbers we like to see. Okay, 5 and 12 are good numbers. 3 and 4 are good numbers if you're talking about tangent, and hopefully you understand why. They can't just give you this. Does everybody understand why they can't just give you this? Because if they just say the tangent is 5/12, where are you? We could be here, but where else could we be? 3. We don't know which quadrant we're in. So they've got to give you this other information, and they're going to either just straight out tell you that you're in quadrant 1 or 3, or they're going to say something like 180 is less than or equal to x is less than or equal to 270. Or they could say pi is less than or equal to x is less than or equal to 3 pi over 2. They could give it to you in degrees or radians. Reminder from the other day, pi and 180 is the same thing. And since it is the same thing, this would be 90 times 3, which is 270. Those two things are the exact same thing. So if they tell you this, that means that you're in quadrant 3, where all students take calculus. The only thing that's positive is tangent. That means sine and cosine are both negative. Reminder of why sine and cosine are both negative is because x is negative and y is negative. So therefore, sine and cosine are both negative. So here's what we do. We draw ourselves a little right triangle. We let this be my x. Doesn't matter really where you put it. But I know that tangent, which is opposite over adjacent, is 5/12. And this is the reason I told you that 5 and 12 are nice numbers that we like to see, because now I have a 5, 12, 13 right triangle. So let's find them all. So if tangent is 5/12, that means sine and cosine. It goes back to those first problems you worked on this chapter, doesn't it? Sine is opposite over hypotenuse, which is 5/13. Since you're in the third quadrant, it is negative. Cosine is adjacent over hypotenuse, which is 12/13. Since you're in the third quadrant, cosine is also negative. You follow so far? Cosecant. In order to find cosecant, just take your sine value and flip it. Negative 13/5. In order to find secant, simply take your cosine value and flip it. Negative 13/12. You're also given tangent up here, so in order to find cotangent, flip the tangent. You get 12/5. So given 1, there's the other 5. There's another way to work that, and we'll focus more on it on Monday. But I do want to start by giving you this, because somebody told me the other day, I had no idea this was true. You have identities in trigonometry. Identities are kind of like formulas. They're always true. No matter what your angles are, it's kind of like a squared plus b squared equals c squared. You could call that the Pythagorean identity. Well, it'd be kind of hard to call it Pythagorean identity, because we actually have a Pythagorean identity I'm about to give you in trigonometry that actually fits the Pythagorean theorem. It is derived from the Pythagorean theorem. And here it is. Sine squared of any angle plus the cosine squared of any angle is always equal to 1. And like I said, I'll give you this identity. This is not the only identity you have. All of these are identities as well. These were all rules for trigonometry. How many trig identities are there? Millions. How many do you have to know? All of them. Not really. There's going to be a formula list of about 15 identities that we're going to use a lot. double angle identities, half angle identities that we actually get to more in Math 113, but we'll start them here in Math 112. But let me show you how this works, just on this last problem. If I gave you that the sine of x, or the sine of your angle is, it doesn't matter what you call it, is negative 5/13. And you needed to find cosine, but you didn't want to do the little triangle thing. What do? You plug this in right here. I do need to point this out though. Sine squared, sorry I haven't done this already. Sine squared means this, the sine of the angle all squared. So why do they write it like this? If you were to write it the other way, if you were to write it as the sine of theta squared, it makes it look like the angle's being squared. If they put it on just the sine, you can tell obviously the sine is being squared. The whole thing is being squared. So it means this, not this. Okay? You're going to find the sine of theta and you're going to square it. So now let's go back to this over here. If you know sine and you plug it in, the sine of theta is negative 5/13. Plug it in, squared, plus cosine squared. I'm going to write it like this instead of writing that COS. Just c squared equals 1. And let's solve that. That's 25 out of 169. You probably already don't like it because we got fractions. Plus cosine squared is 1. Move this over. And like I said, if you don't follow this today, we're going to do more of them Monday. Move this over and subtract it. You're going to have common denominators to subtract them. This is 169 out of 169. When you subtract 25, it gives you cosine squared is 144 out of 169. Last step, to get rid of a square, we square root. So the cosine of my angle would equal positive or negative 12/13. So how would you know whether it's positive or negative? All depending on what quadrant you're in. If you were in the first quadrant, it would be positive. If you're in the second quadrant, cosine's negative. If you're in the third quadrant, cosine's negative. If you're in the fourth quadrant, cosine's positive. On the last problem, it told you what quadrant you were in, right? Said that you're in the third quadrant, so what would cosine be? Negative 12/13, which is the exact same answer that we got. Cosine was negative 12/13. So that requires a little bit of work, but we will use it some because it is vital that you understand identities. This is your most basic Pythagorean identity because it does look like a squared plus b squared equals c squared. It's derived from Pythagorean theorem. So these are things that we will learn and need to know down the road.